Hi everyone, this is Mr. Bozade, and I'm going to go through problem 1 here on worksheet 10 for you. And it says a 200 gram, 20 centimeter diameter plastic disc is spun on an axle through its center by an electric motor. What torque must the motor apply to take the disc from 0 to 1800 rotations per minute, which is about 188.5 radians per second in 4 seconds. Good place to start, as always, is to draw a diagram. So let's draw a diagram of this disc. Let's label the things we know. Specifically, we know that the diameter is 0.2 meters, so that means that the radius is 0.1 meters. And then since our goal here is to find the torque that the motor is applying, well, a good place to start is our new equation, net torque equals I alpha. So we know that the only force or the only torque that's being applied to this disc is the torque of the motor. So we can set that equal to the rotational inertia times alpha. And one thing that I did here is I thought about the shape of this object, and the shape of this object is a disc. So I went ahead and I subscripted that by saying I disc for the rotational inertia. We know that the rotational inertia for a disk has the equation of 1/2 mr squared, so we can substitute that in. Torque of the motor equals 1/2 mr squared times alpha. And then let's do a little assessment of what are our knowns, what are our unknowns. Our goal is to find torque of the motor, so that's an unknown. We are given the mass, we're given the radius, but we don't know the rotational acceleration. So at this point, you're at a bit of a crossroads. You say, oh no, one equation, two unknowns, what am I going to do? Since our ultimate goal is to find torque of the motor, we need to find a different way or a different method to find alpha. And a good place to look, if you're trying to solve for alpha, is rotational kinematics. So let's list out our rotational kinematics variables, theta initial, theta final, omega initial, omega final, alpha and t, and what values we know. We can say that this disk starts with at an angle of 0 radians. It says that it starts from rest with an initial omega of 0 radians per second. It says that it speeds up to a final speed, rotational speed of 1800 rotations per minute, or more importantly, 188.5 radians per second. And it says it does that in 4 seconds. So then we have our variables listed, so now we just need to pick our equation, and we'll pick omega final equals omega initial plus alpha t, so that alpha is our only unknown, because that's what we want to find, so that we will then be able to solve for our torque. And we can plug in our values and solve for alpha to be 47.125 radians per second per second. Now we can substitute that in over here, as I mentioned a moment ago, and our only unknown is torque of the motor. We plug everything in, and we solve for torque of the motor to be 0.047 Newton meters. I think one of the most important things that we saw in this problem is that when applying our net torque equals I alpha equation, sometimes the variables we're given will require us to solve for alpha using rotational kinematics and then substitute that into our net torque equation so that we can solve for something else in our net torque equation. Great, I hope that was helpful, and I will talk to you later. Thanks.